We are now live.
Okay.
Good evening, everyone. I welcome you to this session. Where are you watching from? Let's connect. Session. Where are you watching from? Let's give 5 more minutes for others to join. Okay. So, good morning, good afternoon, good evening, everyone, wherever you are watching us from. And I welcome you all to this session on intelligent mobility and predictive battery management with IoT and artificial intelligence. My name is Ejibode Ibrahim, and I will be your moderator for this session. We are excited to have you all here as we explore how emerging technologies like Internet of Things and artificial intelligence are transforming mobility systems, especially in the area of electric vehicles, smart transportation, and battery optimization. So you agree with me that in today's world, battery performance, real-time monitoring, and artificial intelligence decision making are very critical in building efficient and sustainable mobility systems. So, in this session will help us to understand how artificial intelligence and other connected technologies are shaping the future of the transportation and energy management. So, as the speaker, before I introduce our speaker, so I'll just mention some uh, housekeeping points. So, feel free to drop your questions in the chat during the presentation, and we also encourage everyone to stay engaged and participate actively. So now it's my pleasure to introduce our speaker for this session. So our speaker for this session is Mr. Tolani Akintayo, who is a cloud DevOps and platform engineer. Tolani Akintayo is a cloud DevOps and platform engineer and educator focused on helping the next generation of engineers to build strong foundations in cloud and DevOps through practical real-world learning. He specializes in cloud infrastructure, automation, CI/CD, and system design, with a strong emphasis on how production systems are built and operated in real engineering environments. Through teaching, mentorship, and technical writing, he helps aspiring engineers move beyond service level 2 usage into deep system thinking and real-world engineering capability. His work is centered on developing engineers who can design, build, and operate scalable and reliable cloud systems with confidence. He currently works as an instructor, training and mentoring engineers to develop both technical depth and the mindset required to succeed in modern DevOps environments. In addition, he continues to create educational content and guide aspiring engineers transitioning into cloud and DevOps careers. Tolan is the author of the Startup DevOps Guide, a practical resource that helps engineers understand how DevOps is applied in fast-paced startup environments. His mission is simple: to help engineers not only enter the field, but grow into confident, capable, and thoughtful practitioners who understand how real systems work in production. Through his work, Tolan is shaping a new generation of engineers who can confidently design, build, and operate scalable cloud systems in real-world environments. Please join me in welcoming Tolani. Over to you, Tolani.
All right, thank you very, very much. Thank you so much. I'm glad to be here, and always a privilege for me to share knowledge, add value, and make meaningful impacts to everyone, especially to the next generation of talents. Just like my moderator has said. All right, I think we could jump right into what we have today. Give me a second. Let me share my screen. Okay. Okay. All right. Can you confirm if you can see my screen? You're on the same page.
Yes, I can. I can see your screen.
All right. Thank you very much. So, just like we have today, the topic that I've been given, right, and we'll be discussing in detail about is intelligent mobility and predictive battery management. And I think just before I jump into it very quickly, I took some time to actually go through yesterday's session, the first session, and I from watching the session, I believe that the moderator and both the speaker did an excellent work introducing us into the landscape of EVs, electrical vehicles, and how cloud, helps in the context. So, taking it into what we have for today, we'll be going a bit in depth into it to understand certain things that will give us a bigger picture of what started yesterday. So, stay tuned. You would really enjoy it. All right. So the first thing is to understand that there is a transportation shift, right? There's a shift within this landscape of transportation, and just like we've had, the conventional vehicles and using, fossil fuel, diesels and petrols over the years, and they're actually dominant uh, in most places across the world, and especially in Africa and in Nigeria. But there is actually a shift that we are experiencing gradually. Most people are not noticing it, but it's beginning to. It's a gradual shift, and what is that shift? Is a rise of electrical vehicles in other countries and continents. These has been, has grown in China and other places, but in Africa, especially in Nigeria, we are still experiencing the change gradually. And honestly, right, EV sales are going to keep growing and growing and growing. If you can check the statistics, uh, there have been thousands and millions of EVs, I mean, all across the world uh, over the years, right? And for the next decade, I believe, looking at how the landscape is currently, there will be more and more electric vehicles, deployed into, the roads to be used basically. So one major thing I want you to understand, right, before we even go into that, right, is that the fact that uh, electrical vehicles or EVs, as it is normally called, is more than a car. It's not just a car, right? And like I said, I listened to the last webinar which started yesterday, and Rejoice was made mention of it, right? But I would go in depth more. Electrical vehicle is not just, it's not just a vehicle that is powered by electrical energy. There is much more than that. It is a software system, a software platform that is actually on wheels, right? Quoting Rejoice. Actually, that's how it works, right? Because the the main function, the main part of an electrical vehicle is actually the battery. And the way it works, it doesn't work like a conventional car. It works by generating data. And we'll get into all of that, right? But the one thing that you should clarify, one misconception I want to clarify at this point is the fact that an EV is more than a car. Yeah, is a component of devices connected together to communicate together, generate data, right? And the last thing here is the fact that this industry is going to be bigger and bigger and bigger and bigger. We can see the rise of fuels, rise of fuel skyrocketing year after year and year after year basically. And the coming electric vehicle coming into the space is going to solve a lot of challenges, even though it comes with its own challenges, right? But it's going to actually help solve a lot of challenges relying just on one source that powers transportation, right? Okay, so just like the topic says, right, predictive battery, maintenance and all of that. That is actually the point. The point is that the battery, and when you hear about EV, the major component you hear about is the battery. And why is that? Is because the battery is the most critical component. The battery alone actually account for about 30 to 50% of the overall cost of the vehicle itself. So that tells you that the battery is so important, not just in its cost, but in the value of what it brings to the system, in empowering it, in the data that's generated, and all of those things. It is very, very important. And the battery itself needs to be managed in a way that it can last longer and be used more efficiently. So the battery itself is used carelessly or damaged. What happens is that you need to replace it, and the cost of replacement is high. Just like I said, the battery itself accounts for 30 to 50% of the overall cost of the vehicle, and that is exactly where AWS cloud computing, AI, IoT comes to bridge the gap, right? Which we are going to see shortly. So when it comes to the battery, it's very important that you understand why exactly is the battery important. Why exactly? What are the things that, what are the details? What are the metrics? What are the things that we need to look at when it comes to the electrical vehicle battery itself? There are three metrics that are very important that you cannot miss when it comes to the EV battery, and that's what I want us to look at now. Is the state of charge, the state of health, and the state of power. I'm going to explain, and obviously I'm going to break it down as simple as possible. When you talk about the state of charge, it just means that how much energy is left. So take for instance, the best way you can think of this is take your mobile phone, or let's say preferably an iPhone, right? Check your phone at this moment, how much percentage is left. That is the state of charge, right? That's the same thing when it comes to an electric vehicle. The state of charge is the energy left on the battery. It could be 100% if it's actually a new one or it has been charged up. It could be 50, 80%. However, right? But it just means that it is the energy left in the battery. So you can think of it in different ways, like using your mobile phone. You can think of it like the fuel gauge of a of our normal or conventional vehicle that uses fossil fuel, right? You can gauge and see how much or where the petrol in this case or diesel has reached the gauge. So that is exactly what the state of charge is. Simple and just simple. When you now come to the state of health is different from the state of charge in the sense that it tells you how healthy the battery is compared to when it was new. So it is more of the comparison of saying that, oh, when the EV was bought and the battery and everything was bought at the beginning, right? How healthy was the battery at that point? Then after usage of over, let's say, 3 to 5 years, how healthy is the battery? So that is what you call the state of health. I think iPhone battery. I think it's iPhone, but iPhone batteries as gives you this battery performance. I think, right, that you can see. Oh, your battery has been used. Oh, after you've used the phone for over 3 to 5 years, you can see that, oh, the capacity of the battery is no longer as it was when you bought the phone newly. That's what the state of health means in clear terms, right? So let's go into the state of power. Instead of power, right, it is how much the power the battery can deliver right now at the moment. So the, it's very easy to confuse the state of charge with the state of power, but they are very different. So for the state of power, it's saying that at this current moment in time, how much power can the battery deliver? I'm going to give examples to help you understand better. So when you are in winter or there's a cold temperature, in the environment, the battery may not be able to generate so much power to make the vehicle move from one place to another, unlike when it's a normal room temperature. That is what it's called. That is what the state of power means, right? So at that particular moment, how much power can the battery deliver? So there are various factors like temperature, like I've said, the battery charge level, the battery degradation. If the battery begins to degrade over a period of time, the power it can deliver at a very at the moment might reduce. So I those are the three metrics that are very important, and they are key for us to begin to go on and on as I continue to explain. Right. So in short, you'll be asking that why are these things important, right? The fact is that these are some of the data that the battery itself generates and eventually to the cloud and all of that. We'll get into that. But now, if you have an inaccurate state of charge, meaning an inaccurate percentage of like your mobile phone in case in this context, right? What it does that it creates a range anxiety, and I will explain that. A range anxiety just means that just imagine a driver in an electrical vehicle, maybe to a logistic company trying to deliver a goods or whatever, right? In that case, the driver does not exactly, if you have an inaccurate state of charge, and if let's say the battery is showing the driver, okay, the state of charge right now is 50%, and and actually is about 20%. So what happens is that the vehicle stop working or stop being powered to continue to its destination, um, than what the driver has what envisioned based on what they can see, because we not human beings trust numbers. So in the dashboard, okay, you can see 50%, oh, battery usage left, or but it's actually 30% because the state of charge is actually inaccurate. So that in itself creates a range anxiety of like saying, oh, the driver is taking the vehicle and is not even sure of when the vehicle might stop and all of those things. So that's what range anxiety means. But when you come to the state of charge now, what is the issue there? If you have a poor state of earth disability, right? What will happen is that the maintenance cost will increase. So because the goal of AI, cloud computing like AWS platform is to actually help us to be able to do predictive maintenance, not reactive. That's actually the whole change, right? Because normally maintenance is usually reactive after something has occurred, after the battery has stopped working or has damaged completely or has degraded completely. Then you begin to now find a replacement. How do we change it? How do we improve? How do we work on it? But now, because of intelligence, right, we are not trying to go from reactive to predictive. Can we predict in the next 90 days if this battery would not be functioning properly? And how do we now maintain it quickly? And if you know anything, it is better to prevent it than what prevention is better than cure. So if you are able to prevent something from happening, then the cost of maintenance will be less than when you are actually like replacing the entire battery itself, which is very costly. Like I said, the battery itself amount for 30 to 50% of the overall cost of the EV vehicle. So going to the state of power now, right? The state of power impacts vehicle performance. So, right now the temperature is so cold when the winter, then the battery cannot generate as much power needed to move the vehicle from point A to point B. That is an issue, right? So, that is just to explain those metrics. They are very, very important. All right. So beautiful. This is actually now the focus. The main point is the battery architecture. I want to help you to understand what exactly does the battery actually contains and what exactly does it, what exactly are the components. It's very important. So the battery itself, unlike the conventional vehicle that has just a battery that you can pick and change and all of that, right? The electrical vehicle battery is very different, very very different, which makes it entirely different from a conventional car. So the way the battery is being organized such that there is a cell, right? There is a cell. The cell is the smallest component. A cell can usually have about 3 to 4 volts. Then a group of cells together is called a module, which on average can have about 12 to 24 volts thereabout. Then a group of module becomes a pack, which is actually the actual battery itself, right? So you can see from this diagram that we have here, you can see how we have the cells, small cells, then are put together to become a module. Then collections of modules is now the battery that you would normally see, and that's what powers the vehicle. So has each cell has a contributing factor to the power that the whole pack gives to the vehicle to move from one point A to point B. So a simple example, I'm going to use an example of an electrical vehicle that is very common that you probably have heard about, and that's a Tesla Model 3 long range. So that particular electrical vehicle, contains about 4,416 cells. So if you do your calculation, that is about 96 modules, right? And all of that is just one battery pack, which has a capacity of about 75 kilowatt per hour. So you can see how it works now, and every single cell generates data on its own. Yeah, the cells are not the same. It generates data on its own, like the state of charge. All these data are being generated, right? And if you look at it, it's just a lot, a lot. Like so, I've talked about the cells, the module, and the pack, right? How they are being put together. Now there is something called the BMS, which is the battery management system, and you can think of it like this: a woman body, you have an heart. Your heart is what basically, if your heart is not functioning, the person is dead. Absolutely. So the battery is what powers the vehicle. Without the battery, the vehicle is going nowhere. That is okay. You can simulate. You can look at the battery like the heart. Then the brain of a person. If you don't, if someone is not sane, right? Somebody is not okay, he's not sane. Then he can have his heart still working, but he will not be able to perform effectively and efficiently, right? He's just going to be doing all kinds of things like a madman. Sorry to say, but that is what the battery management system does. It's like the brain of the whole of the whole system within the EV. And what it does is it monitors the voltage, the current, the temperature, everything. It balances the cells, the cells to be in the same temperature to make them, to be together, basically, be able to generate the same amount of power over time. It does all those regulation together. It acts like a brain, basically. And the thing is, if each cell generates data, and now imagine 4,416 cells generating data every like. And the thing is, every zero every I think every 0.1 seconds generates some amount of data. So looking at it as 1 second, which is 0.1 times 10, is a lot, is massive, and that's like 1 sec, just 1 second. So it means that you'll be having about, I think, about 44,000 plus, you know, data being gotten in in 1 second. If you have 416 for 4,416 cells, that's a lot. So times that by an hour, by 24 hours, just is massive, right? And those data are not just collected or gathered, just to just gather them. We want to use them, right, to make the whole battery system more predictable. That's the goal. All right. So let's go into it. That's the goal that we are trying to achieve. Right now, I will look into what destroys a battery and how software actually protects it, because it's not just about the hardware. There's the hardware, but the software becomes the intelligence that helps us to be able to better manage the hardware. That's the goal. So some of the things that destroy a battery, just like you have your mobile phone, the battery spoils and all of that. The first thing is the degradation factors. There are quite a number of factors there, right? You have the high temperature charging. So if you're always using the fast charging to power your EV, obviously there will be an issue over a period of time, because the way fast charging works, that it pumps. I'm going to use the word, pumps high voltage of energy into the battery, at a very fast speed, which over time, what happens within the batteries, that there will be a chemical reaction within the cells that begins to, I'll use the word, degrade, and doesn't become as effective as it used to be, right? So these are some of the issues, or the factors that affect the battery. You can see also, let's say, okay, excessive fast charging. I've talked about that. Extreme temperature storage. Also there, if the temperature is so high, just imagine having your laptop in a very, very, just let's say, in a very, very hot place. It's not the best practice. It's not advisable. The same thing with the battery in the EV, right? It's not meant to be in a so high temperature, right? So there are a lot of factors that obviously affect that a battery does not become as effective as it used to be, right? So it's not just how long you use the battery. There are other factors, and then what we are trying to achieve by having software as an intelligence to help us to be able to manage those factors that would actually degrade the battery. That is the goal, because obviously a battery bought today in the next 5 years would obviously not be as powerful or as effective as it used to be. It's just it. But we can be able to better maintain it so that it can last longer and work better, right? That is the goal. So that's where the software solution now comes in now. Using the software solution, which I will go into the stages and all of that, it helps us to be able to look at how we can have intelligent charging schedules, right? You can be able to have charge limits, when just like your phone, when some phones, right? Most phones right now would have when the phone is full, it stops charging, right? So that it doesn't keep power, it doesn't keep giving powering it even while it's full, because that would obviously affect the longevity of the battery. So the same thing actually happens, and that is where software solution comes in to help us to actually help, and that's a game changer in this whole story, right? So let's look at how that everything actually works, the in and out. If you're hearing about the electrical vehicles and all of those things, how do the data that is being generated by the battery, how do they actually go into the cloud and all of that? That is what we want to look at here. So the the IoT pipeline you would definitely see most times would be this. So the data flows from the battery cell. So I told you that you have the cell, the modules, and the pack, right? So the cells itself, every single cell you saw earlier, they generate data on their own, right? So the data flows from the battery cells to the BMS. So the cells itself generates data. So is that a BMS, which is the battery management system, that does a form of calculation to help us be able to give value to each data. So let's say like the state of charge, how many percentage, the state of health, what is the value, and all of that is a battery management system that does that, right? So the data flows to battery management system. The battery management system, does a lot. It's like a brain, but does a calculation, and there's a value for each of the different metrics, right? Then from there we have something called the CAN. The CAN is like it's the controller area network. Simple. So just the same way you have your wide area network, your internet, whereby you communicate, websites are deployed and all of that. The same thing within the electrical vehicle, there is a CAN, and what it CAN does is it helps to be able to what transfer the data. So the data um, that is actually within the battery management system pass through the CAN bus, and that's how all the components within the electrical vehicle actually communicate together. They communicate to the CAN bus. So, but like, as I was saying, the data from the battery management system pass through the CAN bus, and then now it gets towards what the telematics control unit. That is actually a very important one, because the telematics control unit serves as a gateway to the internet. Is what gives access to the data that we have gathered, and that is passing through the CAN bus to the internet. So the telematics control unit, you can think of it like the gateway of the data to the internet. So within that control unit, you have it's going to have access to cellular or Wi-Fi, let's say 5G or 4G, which obviously gives access to the internet. So those data can now, you know, go to the internet, eventually to the AWS cloud, right? So that is actually how the IoT pipeline actually works. That is a foundational architecture you would obviously see when it comes to the IoT pipeline. So now the data has come into the cloud. Give me a second. Okay. All right, beautiful. The data has gone into the cloud, right? And there's a service called the AWS IoT Core, very, very important service within this context. Yes, is the entry point for the data that is coming into the AWS cloud. So it receives the data, right? So one thing I must mention before I continue that is the MQTT. That is a message queuing telemetry transport. It's just basically a protocol for the transportation of those data to the internet. It does the encryption and of the data and some other amazing things, but it's just a protocol for transferring data from the old IoT to the cloud, right? So let's go on. The AWS ingestion is where I was talking about. The IoT core is the entry point for the data. So it receives the data that is generated by thousands of vehicles, moving in different places. It's receiving those data, and then those data are being received, right? And is stored in a service. We'll get to there, obviously. A service called the AWS time stream. It stores the data, and data is now ready for processing. Remember that the goal of all of this we are doing is to generate intelligence. That's what we need. So then after the data is being stored, now we want to process the data. That is where you see the services like AWS Lambda and Kinesis Stream for processing those data, right, into that service called the SageMaker. SageMaker is a beautiful Amazon service that is used, for AI models. You have models that you can train data on to learn patterns, and at the end of the day, help you to be able to make critical and insightful decisions based on those patterns that the models have been able to see with the data, with those millions, billions of data generated, right? So that's the goal. And just to mention quickly again, the MQTT is a protocol. It's being used because you can begin to think, oh, why is HTTP not used? Why is it MQTT that is being used? All right, let me clear with that. So the MQTT, which I said is a messaging queuing telemetry transport, yeah, is being used, is preferred because it's actually a messaging protocol being built for IoT devices to be able to collect data actually. But what stands us out from, let's say, HTTP is the fact that it is lightweight and it can still be able to connect, and data can still be transferred even with low internet connection or very limited one, to be honest. So that is why it is actually more preferred, and it's built specifically for this use case. All right. All right, let's move on. Beautiful. All right, so we've looked at the whole IoT pipeline, which is very critical. If you are trying to get into the space, and I believe also for um, everyone that will be working on the hackathon. So right, so AWS Intelligent Mobility Architecture. This is just me diving into the each services again. So we have the IoT core. I've talked about it receives the data from the IoT. The data pass through the telematics and control unit. You can still remember, and then obviously that is connected to cellular Wi-Fi, and then goes into AWS, and AWS IoT core receives it. That what allows the protocol that is being used is the MQTT. Remember that. All right. So we have other services like the green grass also, beautiful service. It helps with edge computing. When you have low latency, there's just low latency. Let's say because in Africa, for instance, right, in a lot of parts in Africa, we don't have so much stable internet. This service helps with that. It helps with that. Data can still be be transmitted, even the fact that there is a stable network, right? AWS has been able to help build services that helps with different use cases and solve a lot of problems, which is beautiful. So uh, you have I mentioned about the Amazon Kinesis that helps with the processing, right? So I think I would give it I would give a real world use case that would help you to be able to remember all of these things. Okay, so we have the Amazon time zone I've talked about that it stores the data being received by IoT core. Beautiful. The DynamoDB is a database you can also use to store data as well. S3 a is an object. It's just it can also use it to store files, videos, and all of that. So, but in this case, looking at the pipeline, the IoT pipeline that I showed you in the last in this particular slide, you would see that the Lambda and Kinesis is used for data processing, right? And when data is processed, things even other information can be filtered from it, right? It now eventually gets to where we actually need. What we actually eventually need is that those vast amount of data we now begin to bring it into Amazon SageMaker, which is a service for machine learning model and AI models, and the model is trained on that data, identify patterns, and this is data of histories for the historical data of the battery, millions, thousands of data. So the AI model is trained on it and is able to identify patterns, and the goal is to help us to be able to now make an insightful decision. And obviously because of your end users like the fleet operators and every other person, the teams, other other person working within, let's say, a logistic company, they want to have something that they can view, something that they can see numbers that they can look at and make decisions based on that. That because of that, we use Amazon QuickSight for visualization. So it helps us to have like a dashboard that you can see, oh, the state of charge is about, okay, but this vehicle that we have at this location, the state of charge is 82%. All right. Oh, how is the battery performance? Look, it's still fine, beautiful, and everything goes on and on. You're able to now use that data to make decision. That is the goal of it. So now you can be able to operate with predictive maintenance unlike reactive, right? Okay, beautiful. All right, so beautiful, exactly. AI for predictive battery management. That is the goal. Predictive intelligence is where we want to actually get to. That is why we are asked to bring all this data to the cloud and be able to, store it, process it, run AI models on it, create dashboard for visualization. The goal is to be able to move from reactive to predictive. So predictive intelligence, right? There is something called the remaining useful life, which AI, when SpeedBreaker is trained on data, can help you to be able to predict effectively. That's something that a human cannot do, right? You can't be able to predict effectively. Just think of it like an human birdie, right? Oh, you are moving from one place to another, you are eating and all of that. You might not be able to easily, you can't be able to easily track the let me use the word of the state of health of your health. Let me use your health. You're not able to track it effectively. But if you go to a specialist and they begin to test things like your blood pressure, your sugar, and all those metrics, begin to look at it. It can tell you how fit you are, how well, how healthy you are. So that is what we are trying to use AI to do in this case because of the vast amount of data generated by this battery, right? So it can help us to be able to predict what to call the remaining useful life, the RUL, the state of health, the charging optimization, what are the things that we can do to make the charging optimized better so that we avoid the battery degradation, and we make the battery can be more efficient over a period of time or over a longer period of time than it would actually be if there was no software or no predictive intelligence. Another is a fleet intelligence as well. Like I said, it's going to this all of this is going to be going to be beneficial to the fleet managers, operators, and all of that because they are not able to they are not able to make informed decisions based on the data, based on the visualization, the dashboard that has been given. Right, you can be able to say, oh, this particular vehicle here can take the package or the goods for this logistic company to this location. It still has the amount, it still has the state of charge to be able to take it from point A to point B. So the decisions now are becoming more effective, unlike just casually doing things, and you can't be you now begin to make you are now begin to go with it within the reactive maintenance and all of that. We now have real time tracking. You can be able to know this vehicle is here because obviously there are GPS in place, and even within AWS you have a service called the Amazon location service that can they can provide real time tracking, geofencing. This is just amazing, amazing, and I believe that this is going to be obviously coming. Um, it's going to be increasing as time goes on within the African landscape, right? And what is the value of all of this for the business? Well, number one is the lower maintenance cost because now you are now being predictive rather than being reactive. You are able to know exactly when the battery, let's say the next 90 days, the battery will not be as effective as it used to be. Then you begin to put in maintenance begin to put in maintenance criteria into it. Oh, this battery, let's check it. Should we replace it at this point? And all of those things. Unlike when the battery is even just down itself, you reduce downtime because if a driver cannot exactly know accurately, oh, the state of charge is like the percentage left for the battery, and the car just stops at nowhere. That is not going to be very good, right? But now you are able to know instantly, and you can say, oh, I need to find I need to be able to the GPS is going to find the nearest location to a place to charge, right? And you go, and everything becomes smoother than it used to be, right? The battery lifespan is going to obviously increase because now you are able to maintain it better and better and better. Better customer experience also because if you are moving goods from one place to another and the car stops because you don't have the required information for the battery health, and the customer is delayed, you have to send another vehicle and all of that. It's going to take time. Time is there, customer experience, all of that. But with this, with AI for predictive battery management, you have better customer experience, which is amazing. So the whole goal of these, right, is the fact that you can make informed decisions, you can make better decisions, right? So let me see quickly. Give me a second. Okay. I want to. Can you still see my screen, please? Just want to confirm that. I hope I
Yes,
didn't lose
yes.
anyone.
I can see your, I can see your screen.
How about now? How about now? You can still see my screen.
Yes.
All right, perfect. So before I even go into, let's say, how future trends, I want to give you like a simple reward scenario. I've explained it, bit and bit during the conversation, but take a logistic company that has about, let's say, 5,000 electrical vehicle, vans that are delivering different services and packages. So one vehicle, you get information, and it says, oh, this vehicle. All right, sorry. It says this vehicle has. I'm getting this. Sorry about that. All right. It says this vehicle has 82. The party charge is 82%, and everything is fine. There are no warning lights because there are no symptoms of the fact that this battery is going to be it's going to break down. Let's say in the next 90 days and all of that. oh, deliveries can still go on as it used to be. There are no subtle pattern of, let's say, oh, the battery will need maintenance in the next 90 days and all of that, right? If that was the case, if you could not see all of that, the driver would not know anything. The operations team will not be able to make informed decisions quickly and fast and as possible. But because of the data that we have now and the services that I've described, like the AWS IoT core, the time stream for storing historical data, battery data, Amazon Kinesis for processing those data as well, and then the SageMaker for now you are running machine learning model on those data. Definitely you will use a service called Amazon SNS, which is just a simple notification service for alerts, right? You could have different conditions put in place. Let's say if the battery state of charge is less than, let's say, 50%, oh, alert the fleet manager to be able to know that, oh, this battery is about 50%, or where is the location that we can quickly charge this before it goes lower than this, and all of that, right? So mm, the goal of everything is to say, and I've been saying, is the fact that you can make more informed decision by having your intelligence. So the hardware is obviously on the road moving, but the intelligence, or let me say the data, is gotten within the vehicle, right? But the intelligence that runs and helps to be able to manage the EV is in the cloud. So that is what actually makes it a game changer. So some of the future intelligent mobility that we'll begin to see as time goes on. All right, just give me a second. All right, now we'll begin to see as time begins to goes on is very good to read. I remember the moderator for yesterday's session mentioned this as well, which is awesome, right? It's just the way that these batteries begin to give power back to the grid is mind blowing, to be honest. You begin to see solid state batteries that are more powerful, stronger, can hold more power, can last stronger, and all of that, right? Obviously, all of this is going to basically create a lot of opportunities as well, right? It's amazing. And then for us in Africa, to put it in context, looking at how that these EVs is obviously gradually growing from Abuja, to Lagos and all of that, and other African countries, we will eventually begin to see an increased demand on this, right? Because we begin to see how effective it is compared to the conventional vehicle, and looking at the increasing rise of fuel, the increasing cost, I mean, of fuel. We begin to see that will eventually begin to tilt towards the EV vehicles, right, which are more going to be efficient. So, just to wrap this up at this point in time, the most important thing is this: every electric vehicle generates data, but the game changer is what you do with the data. So the companies that will win are those that have the best data pipeline, just as you can see on my screen, the best predictive model, because the more effective your model is, the more effective your decision will be, right? So best predictive model, best fleet intelligence to make informed decisions that makes your um, overall delivery or overall activity within the company more effective. So if it generates data, but the question is, are we using the data to create intelligence? That's the major thing about all of this that I've been saying. So to wrap up very quickly, right? I think I have a minute or so. Very quickly, there are a few takeaways I want you to go with, and that is the fact that data is actually the new fuel. We've seen this over the course of the years, not just in EV, but in data analysis and other fields, right? Now, EV generates massive amount of telemetry data, but the question is, how do we use it to form intelligence that we can make informed decision on, right? Because you having your intuition or thinking, oh, this I think this battery is too big, does not is not as effective as having an intelligence backed up by data, right? And software is going to help drive that longevity definitely. So it's not a case of the hardware alone. It's a case of the hardware and the software working together to make things more better. So software is going to help with that, as I've discussed throughout this whole conversation. All right. So I think I'm going to stop at this point and I'm going to collect questions. So thank you very much. You can definitely reach out to me on the various platforms on the screen.
Yeah. Wow, thank you very much, Tolani, for that very insightful and engaging presentation. It was very informative, especially the insight you shared on how IoT and AI can improve intelligence mobility and how it can enable predictive maintenance. And I'm very sure everyone has learned something valuable from this session. And we sincerely appreciate you taking the time to share your knowledge and experience with us today. At this point, we move into the questions and answers session. If you have any questions, kindly drop it on the chat. Okay, can you still hear me?
Yeah, I can hear you definitely.
Okay. So there is one question from Mr. Prince. The question reads, thank you. How does the fleet managers manage the data from different vehicles? Won't it be too much to handle?
All right. I think that's an interesting question. So, like taking an example of having about 500, let's say 1,000 EVs on the road, and you want to track data from it and all that. Yes, it's going to be a lot, but that's where the software part comes in. Like I was explaining earlier, when those data are being trained on the machine learning model, obviously there will be a I said earlier that we have another service called the Amazon Site, which gives you basically give you a dashboard, right? Just something that you can view and see, oh, this particular vehicle, this is information, the state of chart, the metrics of it, and you can make informed decisions based on that. So I understand what you're talking about. So the way it works actually is that every vehicle obviously has a unique identity, just like the normal vehicles has their plate number that you can use to identify them, right? So in that same way, because when the data that is actually coming into the AWS IoT core are coming in that pattern, I would have shown you one of the ways it looks like, right? But we don't have so much time. But you would have, like, let's say the unique identity of this particular electrical vehicle. Let's say um, Tesla 001, for instance, I'm just saying, right? And then you have the state of charge. Every information particular to each vehicle is within it. So if the fleet manager, obviously the fleet manager knows how many vehicles is being dispersed uh, into the into the road to go and probably make deliveries or do logistic, all of that. So based on they obviously have that information. Oh, 50 vehicles have been dispersed into the road for delivery, right? So they're going to be tracking those information within the dashboard. And the beautiful thing is this, right? Because you can't obviously be looking at 50 vehicles all at the same time. And that's the game changer. The game changer is the fact that not all the 50, the goal is not to see all the 50 vehicles, right? Even though you can, the goal is to be able to know the vehicles that are going to be having issues, so that you can take a predictive action towards it. So if a vehicle is doing fine, why do I need to be checking it? I don't think I need to, even though I can. So that's where you have what we call the service that will basically notify you if there is an issue with a particular battery of an EV at a particular time. So it's not like you'll be getting all of, let's say, 50 EV vehicles at the same time. No, no, no. You don't need all those information, even though the information are available. The information you need is how the software can help you to better manage the EVs, right? So I don't know if that clarifies the question. I hope it does.
Okay, so the questioner asked further question that reads, Since the infrastructure is in the cloud, won't it lag in areas with low or no internet connection?
All right, amazing question. Amazing question. So that is actually an issue, but the beautiful thing is that we have services within AWS that actually helps to solve these issues, right? So services like the AWS IoT Greengrass, and I'm thinking, I'm just trying to remember that service now. These services are built specifically for areas whereby they are unstable or low networks. So the way it's going to work is that even though, let's say, even though you can't get data at real time, those data can be stored, and can be stored, right? And then when the EVs gets to their, their obvious destination, where they would eventually obviously have connection to the internet, those data are then transferred to the cloud, right? So eventually you will still be able to have your data into the cloud. So if for areas where there are low internet, or let's say there's no connectivity at all, those data can be stored, and when those, if it gets to their destination, where definitely there will be internet because of how they operate, right? They would have access to the internet, and those data will now be uploaded into the cloud. And this is the thing, right? Even as much as in areas where you have a good internet access, you can have real time monitoring. The goal is this. I want you to understand something, is that the what we are tracking, right? You're not just tracking just the data of today. You are tracking data, like historical data of, like, let's say, months, because that's what the AI would, the machine learning models in SageMaker would use those data and to learn patterns. So it's not just data of today. You can't obviously effectively make decisions or even create models, or train data, train models on data of just let's say, just in few hours. You can, but to make it more effective, that should be data, let's say, for months, even years, because patterns are not clear at that point. So I hope that answers your question also. Right.
Okay.
Mhm.
Uh, okay, thank you. Then I also have a question.
Okay.
Um, do you think artificial intelligence will eventually eliminate most battery failures in all these electric vehicles?
Do I think it would eliminate most? All right. So if you say most,
Battery
so
failures.
okay, yeah. All right. So this is the thing, right? The fact still remains that a battery used over time would be less efficient as it was when you bought it. That's the normal fact. Nothing can change that, right? But the the usage of AI, the cloud infrastructure, is to help us to manage some of some of the things that cause degradation in the batteries, like fast charging cycles, and the driving habit of drivers. Of some of these things can be managed better. And if you don't have data to say, oh, this is what is happening, how can we improve it? You will not be able to see clearly on what to actually improve. But now that we have the data, and they are being trained, they are being insight and decisions are being gotten from them, we can now make informed decisions. So to your question, it cannot eliminate things like, let's say, the age of the battery. Obviously, a battery you bought today and used for the next 5 years will not be as effective as it used to be. That is normal. But it will be able to help us limit, reduce some of the things that can actually be worked on, like the few things I've said. So that is what AI is going to help us to do, to make informed decisions, to make everything more better when it comes to, for instance, logistic companies, their transportation of goods and services. It's going to make things a lot more better. So for every technology, like it has always been and it will always be, there's always a pros and a cons. The goal is not saying that it will come, AI will come and solve everything. AI doesn't solve everything. No, but it can make us more effective, productive in certain areas, which is what we want eventually, to improve and be more better, to optimize it more better. So I hope that clarifies the question. It's not going to just stop everything. It's
Yeah,
going to improve what is on ground.
it does. Thank you very much. Solani.
Yeah.
And once again, thank you very much for the excellent presentation. Um, and to everyone that has joined this session, we say a very big thank you to you all too. And we hope we see you in our future sessions. And quick one, the last session will be holding tomorrow, 5 p.m. same time, yeah, same venue. So don't miss out. Thank you very much, and have a lovely day. Thank you.
All right. Thank you so much. Bye.